and here we are going to solve problems based on realization of FIR filters in terms of a direct form and also cascade and also linear phase. First, if I go in a direct form, this is the general diagram. Already I hope you all taken off this diagram. This is the general diagram. Remember h of n based on this how many delays function are going for. Based on that we are going to take a delay function as z inverse based on how many delay functions are there in a given equation. Based on that, and what is the coefficient of those, that is h of 0, h of 1 to up to h of m minus 1. This is the general form of a direct form. Remember this direct form. Next, if I go within a cascade form, observe here we have to remember what is the equation is going for. When I am going to take with the equation, given equation represent in terms of a yk of n here in this equation. bk0 x of kn, bk1, it depends, bk0 1 bk2, it depends in which how many it's given. Okay, here how it can be represented, here it is shown, that is x of kn is going to be taken here, the coefficients are represented, here it is the delay functions are represented, and you will be getting the output. The same cascade form can be represented here in a two forms, that is h1 of z and h2 of z. How it is two different forms it is going to taken from the problem we can understand. Okay, remember these two and the equation for cascade form. Okay, next one more is of which one, it's of a linear phase. Here I am going to solve a problem based on where your m function is of a odd one. For that reason here it is shown, we already taken a general form how it is going for, it's here taken as m for number 9. Okay, m is value is 9 because it's odd number. Okay, this is the general form. Remember how the general form is going to be drawn, how the your delay parameters are going to be taken. Okay, here x of n minus 1, here is x of n minus k 8, sorry, n minus 2, n minus 3, 4, it depends based on the equation how much it's given for us. Okay, but remember how a structure is going to be drawn. Okay, this is about your linear phase. It may be for m value odd or it may be for m value even numbers. Okay, first we will take the first problem here. Here it is asked to find realize the linear phase FIR filter with the following impulse response. What is the impulse response is given? H of n is equals to delta of n plus 1 by 2 delta of n minus 1 minus 1 by 4 delta of n minus 2 plus n of delta of n minus 4 and 1 by 2 delta of n minus 3. This is the given equation. First, take on the given equation as it is, then take, if it is in terms of a time domain function, given function, then convert that to in a z domain. Okay, here to get the z domain equation, we have to, what we have to do, we have to take z transform for the given equation. So if I take z transform for the given equation, I will be getting as h of z is equals to 1 delta of n, for delta of n z transform is going to be 1. If it is of delta of n minus 1, it's going to be taken as z raised to minus 1. Okay, here is also we taken the same thing, delta of n as 1, delta of n minus 1 as z inverse, the coefficient remains same, then minus 1 by 4 z raised to minus 2. Then here I wrote the first n minus 3 and then n minus 4. So 1 by 2 z raised to minus 3 and delta of n minus 4 I can write as z raised to minus 4. This is about taking a z transform. Next, we know that what is the system function. We already know output by the input, that is y of z divided by x of z. If I want y of z, because in the equation we want what is the output, for that reason y of z is equals to h of z into x of z. Same, we know what is our h of z, multiply with the x of z. Write h of z as it is and multiply here with the x of z. Then each parameters in this case multiply with the h of z. Then you will be getting the equation of this. That is y of z is equals to x of z 1 by 2 z inverse x of z. Like this you have to multiply for the whole function with the x of z. Okay. Next, after taking this, we will be getting a equation in terms of z transform, but in a standard form we want in terms of a time domain. For that reason, again take the inverse z transform, then y of n. If you know how to convert from time domain to z domain, again z domain to your time domain, as we done in the signals and systems. Here also again convert the given z transform into your time function, that is y of n, y of z to y of n. If I take that, your x of z I can write in x of n. Again z inverse can be written as 1 by 2 x of n minus 1. If it is of z raised to minus 2, I can write x of n minus 2. Coefficient remains same and sign is also remains same. Remember this. Then plus 1 by 2 z raised to minus 3, I can write as x of n minus 3. Then z raised to minus 4 x of z, I can write as x of n minus 4. Then rearranging the terms, because here the coefficient, we are mainly focusing on coefficient. If the coefficients are remain same, write those in one side and remaining other side. The same thing is here done. X of n coefficient is 1 here, and also for x of n minus 4 here also coefficient is 1. For that reason we taken here. Next, n minus 2 is having 1 by 2 x of n minus 1. Here 1 by 2 x of n minus 3. For that reason from this I taken 1 by 2 x of n minus 1 plus x of n minus 3. 1 by 2 is taken as a common here. Next, the remaining part is of only of this part, so write as it is here. Okay, this is all about what you have to follow while you are going to do problems on linear phase FIR filter. Okay, this is the basic steps for all the problems, but remember whether the equation is in terms of a time function or they given directly z transform. Okay, they may give as directly as z transform, or else they may give in a time function, convert that to z transform, again convert that to inverse z transform. Be ready with the equation. After taking this, remember what is the linear phase diagram. Here x of n, input is going for x of n minus 1, here x of n minus 2. What are the parameters we have? X of 1, 2, 3, 4 and 5 we have. Okay, but the structure, remember this diagram, and again we go with the what is our problem. Okay, based on this equation, input is of x of n, x of n is taken as the input. Then for that, what the another parameter, it's of x of n minus 4, means 4 delay functions has to pass, and then it's going to be added and it's going to be multiplied with 1, because here coefficient is 1. For that reason here it is going to be taken as 1. Okay, x of n minus 1, then here x of n minus 4, n minus 2 is there, take here n minus 2, then multiply with the which coefficient, minus 1 by 4, take this minus 1 by 4, represent here. It's going to be taking and it's directly going to be added. Okay, this term is finished, this first term is finished. Next is of n minus 1, n minus 3. N minus 1 I will be getting from here, n1 minus 3, n minus 1 sorry, from this n minus 3 multiplied with plus 1 by 2. For that reason, first we are going to implement this and then multiplying with the coefficient value, that is x of 1 is equals to 1 by 2. This is one method to draw a linear phase. One more method what you have to do is, here alternate method is, what is the given function we have to write as it is, then take the each coefficients here, that is here it is 1, here it is 1 by 2, here it is minus 1 by 4, 1 by 2 and then 1. Represent those as h of 0 as first, h of 1 as second, h of 2 as minus 1 by 4, h of 3 as 1 by 2, h of 4 as 1. If you represent the coefficient values in the equation, you will be getting the same here. Observe here where we have, this is the full structure, but we want only of the half part, only the half. For that reason, h of 1, h of 0, h of 1, h of 2, again h of n minus 4 is also 1. For that reason, the same coefficient is going to be taken place. This is how you can directly represent, or else by using the equation also you can go through. This is about the problem based on linear phase FIR filter. Compare a standard generalized equation realization and then solve the problem. It will be easy. Be remember the generalized form for the linear phase FIR filter. Okay, this is the one problem which is asked in the exam for 6 marks, or else sometimes they may ask for 4 marks also. Okay.